Now that we have the parts placed on our board, we're going to look and see what it takes to get the copper routed. Well, all these white lines are the net connections. That's the connections that need to be made in copper. And there's a few ways to do that. We can always select our layer. Look on the bottom and left here, top layer, bottom layer. We can select these layers. So if I select top layer, it's possible for me to route this by hand. I can come up and say interactively route connections right here, click on it, and then I can come here and start routing. You can see I'm drawing in red because red is the top layer. I can connect. You'll notice that I cannot connect to things that are not the correct net. Look, I can zoom in here. It will not let me connect here because that is not a proper net connection. It's not ground. Now this ground does go over here. So that's one way to route. That's probably your best way to route. On very, very simple boards you can auto route, and I'll demonstrate that. Let's take route, unroute all. I'm going to undo what I did, so unroute all the connections. I can go to route, auto route all. Default is the default 2-layer board. I can tell it route all. And here you go, 25 connections. There's 25 of 25 routed, less than a second. Routing finished with 0 contentions, failed to complete, 0 connections. Very good. Let's talk about what that means. A contention would be this trace trying to get over to this trace, but this one's in the way. That's a contention. It's trying to get over the cross and it can't find a way to get around it. That'd be a contention. Obviously, unrouted nets are nets that didn't get routed. If it wasn't routed, I'll show you what that looks like. Let me just highlight this blue line. If it's not routed, see that white line? That's telling me it's not routed. I need to continue routing that. For some reason, it didn't get routed. All right. Now I see my defaults. I'm looking at this. It's routed. They're all very thin traces. Maybe that's not what I want. So I'm going to go to the unroute and tell it unroute all. And we're going to look at some of the rules because I can set rules here. They're going to tell us what's going to happen. So let's go to design, rules. And I have a few things I can look at. There's clearance, which is telling me how close things can get. And there's width that's telling me the thickness of the trace. So I'm going to adjust this. I'm going to tell it, no, I want it to be 20 mils instead of 10. A mil is a thousandth of an inch. So instead of 10 thousandths of an inch, I'm 20 thousandths of an inch. So I'm going to tell it apply. OK. I can go back to my tools and reset the error marker so I don't have to see that. And I can tell it route. I'll tell it to auto route him again. Let's see if it looks any different. Oh yeah, look at that. These traces are heavier now. I have fatter traces. That's good. So that's a good thing to do. You can make your traces fatter if you can. They're just more robust. They can carry more current, less voltage drop if they have current running through them. It's just smarter. There's less inductance on high frequency signals. So we try to run them heavier if we can. Let me show you another way to adjust your rules. I'm going to go back to my op-amp power schematic and I'm going to tell it I want to place a directive. Alright, so the directive is going to be, I'm pretty sure it's a parameter set. There we go. Before I place it, I hit tab so I can adjust. This lets me adjust things before I place it. I'm going to adjust the rules. I want to add a rule. And what do I want to change? I want to change the width. I want to be able to make one net have a thicker trace than the other nets. So let's go to routing width constraint. I open this up and I can tell it I want, wherever I put this, I want that net to have 30 mil traces. So I'll unpause it. I'm going to put that on ground and save this. So now I've put a directive on my schematic to make an exception in the rules for this ground connection. So let's go to design, update my PCB document. It's going to add this rule. Oh, look at that. My ground lines are green now because the rule changed. They were routed at 20, but I set a rule they needed to be 30. So I'm going to come here, unroute all, reset the errors. I'm going to tell it route all, and we'll see what happens. There we go. Now look, my ground is a 30 mil trace. All my other traces are 20. Now at any time I can click on this. You see it's highlighted. I can come here to properties and see what's the properties of this trace. What's going on with this one? Here you can see the length, the location, the properties, right? The width is 30 mils. It's a top layer. Be aware that you can change these things if you want to. This is a top layer. Watch this. I want you to be a bottom layer. I can highlight this one and tell it the same thing. Now I just move those traces to the bottom. That's a very useful function to do when you're using your properties. Now if I'm doing a bunch of changes, look at this little push pin up here. You'll notice if I come over here and click, the properties goes away. Same with components. If I come over here and click, it moves out of the way. If I need to use the properties a lot, I can take that thumbtack and push it in there and it won't go away. It'll stay there as long as I'm doing this, and I can keep looking at other devices, other traces, other parts, and get the properties of those parts. So that push pin works on any of these. I can do that with projects. Push pin, the project stays there, it never goes away. I lose space. I like to have the space, so I like it to pop up when I need it and go away when I don't need it. Now I will still suggest that for a simple board like this, you can auto route. For your normal projects, you're going to want to hand route it. You want to come up here to this toolbar here, interactively route connections, and route all your traces yourself, because you can control where they go and what they're doing. Once in a while people will hand route some traces, the important ones, and you can lock those traces and then let the machine route the rest for you. Let's see, we can do this. I'm going to tell it unroute all. And I can come up here and say maybe I thought that this was an important trace and I wanted to route it by hand and I didn't want it to move. You'll see if I come up here to the route, AutoRoute all, I'll have an option. Lock all pre-routes. I can do this and say, man, I already routed that, don't move it, and tell it route all. Now it'll route the other connections, and it left my hand routes alone. So that's another option you can use, to hand route the important ones and then let the auto router finish the rest. Always be smart and go back and look at it. It's once in a while Altium will screw up and you may not have a connection, or you may have crazy things that I see it do when it routes. Sometimes you'll have something that looks like this. You'll see a connection here and then it'll do this. It'll come, let me zoom in, and it'll do this. Well, see, it's getting rid of it for me. It'll make like a little diamond. You'll have an extra path in there that doesn't need to be there. So keep an eye out for that. It's always smart to look at that and try to take care of it yourself. Alright, I think that's going to be it for this video, and we'll continue with the next video.